Okay, if you didn't catch the first half of this, you want to go back and check it out. But up until this point, we've been talking about arithmetic sequences, and we've got as far to say that there is an algebraic definition, and we have another written definition, but generally arithmetic sequence is a sequence in which each term differs by the same amount. Now I know a lot of you guys would sooner just have an equation that you can just plug in the numbers, but before we actually get an equation, I want you guys to think about how you arrived at that equation. Equations are much easier to memorize, or not even memorize, they're much easier to use if you can create them yourself. So let's figure out how the general term for the arithmetic sequences, the formula is actually derived. So let's say the first term of an arithmetic sequence, which we might call that term un, but in fact since it's the first one, we're going to take out that n, because n just tells us what term number it is, and we're going to call it term number 1. So it's u1. And then let's make another statement. Since we know that the difference is always a constant, we're going to say that the difference in this case, the common difference, is d. And d we're just stating the fact that it is a constant number. It never changes. That number that differs between the first and second term, second and third term is always d. Knowing this, we can actually create a statement. We know that since the difference is the same, you can actually find out u2 by adding the difference to it. This is what I mean. So all you have to do is add the first term plus the difference to get the second term. If u2 equals u1 plus d, then we could also say something about the third term. So we can actually find u3 by simply taking the first term, u1, and doing the difference twice. So adding the difference twice, once to get to u2 and one more time to get to u3. In fact, if we wanted to, we could also find that u4 is simply u1 plus 3 times the difference, because we've had to go one time to get to u2, a second time to get to u3, 3 times to get to u4. In fact, in general, we could make this statement. So this is an important statement. What we're saying here is that you can find out the term un simply by taking the first term, u1, and adding d times 1 less than the term number. So 1 less than the term number. Now, if you're wondering why, take a look at the previous example. u3 was found by taking u1 plus 2d. u4 was found by u1 plus 3d. So it was always 1 less than what the actual term was. So this is the formula for those people that love to use formulas. That is it. So that's definitely something that you want to include in your notes very clearly. Okay, let's try an example, something that you might actually see. So let's consider the following sequence: 2, 9, 16, 23, and 30. Now if you stare at it long enough, you'll figure out that there is an arithmetic sequence going on here. Now to prove that, we could actually just look at each one and find out the difference. So between 9 and 2, the difference is 7, 16 and 9, the difference is also 7, 1623 is 7, and 7. So there is a constant difference. In fact, d is equal to 7. If we were to insert this into the general formula that we found up above, here we could say that you can find whatever term you want by adding our first term plus n minus 1 times our difference. Now we know what our difference is. Our difference is 7, still n minus 1. We now also know what our first term is. Our first term was 2. So now we have a general formula on how to solve this. We can find out whatever term we want simply by taking 2 and adding whatever that term is, minus 1 times 7. So how about 100th term then? So look at the solution below.